Hi guys, today I'll talk about some of the overlooked functions in the Itertools module. With these functions, you can write Python code in a more functional way. The Itertools module exposes a number of functions that you can use to iterate and operate over the data structure, like list and tuple, in a very memory efficient and performant manner. Let's get started with the count function. At first, you want to import the Itertools modules. There you go. And then the first function we're going to look at is the count function. So count returns you an indefinite iterator that you can loop over. It takes in two optional arguments, start and step. So count takes in start and step. Start defines the number where you start counting, and step defines the increment between the two generated numbers. For example, if you do a count of 5 and 2, the generated numbers will be 5, 7, 9, 11, 13, and so on. As you can see, you start from 5 and then you generate numbers in the increment of 2. This function can come in handy when working on data-intensive applications. Let's say you have a bunch of consecutive data points and you want to give them an auto-incrementing monotonic ID. You can do something like this. Let's say we have a list of data points. Each of the point is going to be a tuple with, let's say, coordinate x and y. And let's do 3 and 4. And then let's create the iterator that is actually going to be generating the ID. So we can do itertools.count. And then given the ID we're giving the data points is auto-incrementing, we want to start from 1. And then for every successive data point, we want to increment our counter by 1. So we can start from 1 and our step is going to be 1. Now let's actually loop over the data points to give them, to assign them an ID. So we can do for point in data points. Let's just print it out. Let's say give it an ID. And let's say the ID is gonna be the next element in our iterator. And we're gonna print the payload, which is just gonna be the point. So let's print this out and see what we're getting. Let me run it here. As you can see, as we're iterating through the data points, we are giving them an ID, which is auto-incrementing and monotonic. You don't need to know when your data point is going to end, because the iterator that you're generating here in line 7 is indefinite. So as long as you're only going next and next in the iterator, you're always going to be incrementing the counter by 1. Alternatively, you can also use the iterator to loop through. Let's say you want to indefinitely loop through all even numbers. So let me remove the example we have over here. And let's say we create an iterator of even numbers. So even number generator. And we're going to do it using the count function again. We're going to start from 0 and then increment by 2 because we want to generate even numbers only. And then let's iterate through the iterator that we are generating. So let's just print it out first. And if I run this, it's gonna be too quick and our program might crash because, as you know, this is generating an indefinite list of even numbers. So let's just import the time module. And then we wanna, after we print out the even number, we wanna sleep for 2 seconds. This way we can actually see every number that we are generating through that iterator. Okay, so let us run this now. So pay attention to the terminal below. So as you can see, we're starting with 0, and then 2, 4, 6, 8, 10. As you can see, we are generating even numbers every 2 seconds. And given this is an indefinite iterator, as we're looping through it, we're gonna pretty much indefinitely keep on going through it until we break out of it or just close the program here with like Control C. There you go. The next function we're going to take a look at is called cycle. So let me get rid of this. So yeah, cycle, yeah. So cycle takes in an iterable and returns you an iterator that you can loop over indefinitely, wrapping to the beginning again every time the original iterable is exhausted. Let's look at an example to make it clearer. So as you can see, our function cycle takes in an iterable. Okay, let's go through an example now. Let's say you want to divide a group of people into different sections evenly. Let's say we have a list of people here. Let's just go with some random names. Let's do Ben, Mike, Jerry, Amanda, and Jeremy. And then let's say we have 2 sections only, 1 and 2. And we want to divide all these people into these 2 sections evenly. So we want to assign Ben to section 1, and then Mike to section 2, and then Jerry again to section 1, Amanda to section 2, and Jeremy to section 1. As you can see, every time we're out of sections, we want to wrap around to the beginning and assign that section to the next person in the list. See how we can do that. So we want to make an iterator with the sections list. So let's call it section iterator. And let's give it a cycle, and then let's give it our iterable, which is sections. The iterable can be anything that you can iterate over. So in this case, we have a list, but it can be a tuple, it can be a string, it can be a dictionary, it can be anything you can iterate on. So we have the iterator here, and then let's iterate over each of the person we have. And we're gonna print out a template string, which is gonna be the person, and we have the name of the person here. And then we're gonna assign a section, and the section is gonna be the next element in our iterator. There you go. I hope I got the parenthesis right. Okay, let's try it out. So as you can see, we're assigning Ben to section 1, Mike to section 2. When we're coming to the next person, Jerry, as you can see, our sections list here only has 2 elements, and we want to divide the people evenly. That's why we're wrapping around and assigning Jerry to 1 again, Amanda to 2, and then wrapping around again with Jeremy. So as you can see, I'm pretty sure you can think of quite a number of use cases that can really benefit from this function. The next function we're going to look at is called combinations. So let me get rid of the examples we had here. Combinations. Combinations takes in 2 arguments. One is going to be an iterable, another is going to be an integer. Okay, and what the combinations function does is it's going to return r-length subsequences of elements from the input iterable. So let's say the integer we have here is called r. So what the combination function is going to be doing is it's going to return r-length subsequences of elements from the input iterable that we're passing in. Let's look at an example to make it clear. Let's say you have a list of food and you want to decide how many ways you can eat a pair of them. So let's say we have a list of food here, and then let's just give it pasta, burger, sandwich, pizza, ramen, and dumpling. So as you can see, we have a list of food here. And then the first thing we're going to do is we're going to create the iterator with all the combinations. So let's do Itertools.combinations. Give it the iterable, which is the food, and then the length we're passing is 2. What this is going to do is it's going to take in the iterable here and then return you an iterator where each of the element is a combination of 2 food from this iterable. So you're going to get all possible ways you can have 2 food from the list above. So let's print it out so that we get a better understanding. So for pair and food pairs, it's not Paris, it's gonna be pair. There you go. We just wanna print the pair. Let's run it and see what we get. As you can see, we're getting pasta and burger, pasta and sandwich. And then if you come down here, we're getting sandwich and pizza, sandwich and ramen. As you can see, we're getting every combination of 2 foods from the food list here. The iterable you're passing here, so the example we're going through, I'm passing a list, but it can be any iterable from a string to a dictionary to a tuple. The next function we're going to look at is called chain. So let me get rid of this. What chain does is chain takes in a bunch of iterables. So it can be iterable 1, iterable 2, iterable 3. And what it does is it provides you a memory efficient way of looping through multiple sequences consecutively. Let's look at a practical example to make more sense out of it. Let's say we have our first iterable called numbers1, which is going to be pretty much a list of 10, 20, 30, and 40. Let's say we have another iterable here, which is a list of 50, 60, 70, and 80. Let's say we have yet another iterable here, which is going to be 90, 100, 110, 120, 130. So there you go. We have 3 iterables over here. And let's say you want to loop through all these consecutively. So there are multiple things you can do. The first thing you can do is just individually iterate through them. So let's say you can do for num in numbers 1, you can do a print num. Let's copy paste this one 3 more times. There you go. And then we're gonna do numbers 2 and numbers 3. Run it, and you can see we're iterating through all of them. But the problem with this is even though we are looping through them consecutively, we do have to write 3 separate loops for that, which is very verbose, and we don't really want to do it in Python. The second way we can do it is we can create a new list called combined, which is going to be the sum of all the above. There you go. Okay, and then we can iterate through this combined list. Comb and combined. Let's just print comb. Let's see. As you can see, we're printing out all of them the same way. However, this has great memory overhead as you're creating a new list from the existing one, which doubles memory usage. So let's say we have a list here, a list here, and a list here. And let's say each of them is taking let's say it's taking 10 megabyte. This is taking, let's say 5 megabyte. And this is taking, let's say 30 megabyte. When you're creating the combined list over here, you're pretty much duplicating everything. So you're ending up with the data structure that is 45 megabyte. So you're essentially doubling whatever your total memory is here, just so that you can iterate through them. which, as you can imagine, with tens of millions and billions of items, can get very, very expensive. This is where our function cycle comes in. What you can do is let's create the combined list, but this time we can do it with our chain function and give it however many iterables you want to iterate through. There you go. And then we're just going to do it the same way. There you go. As you can see, we're doing the same thing as we did before, but now the code is much more concise and also very, very memory efficient because we're not duplicating any of this list. We're just chaining them together. The last function we're going to look at is called compress. So let me get rid of this. And then let's look at compress. So compress takes in two arguments, the data and selectors. Both of these are iterables. Data is your main iterable that contains your main data. Selectors is an iterable of booleans. It defines whether an element in the same position in the data iterable should be filtered out or not. Let's look at an example to make more sense out of it. Let's say we have a list of cities over here. So we have Atlanta, San Francisco, Seattle, and Houston. And let's say we have our selectors here. It's going to be true, true, false, and false. With compress, what we can do is, okay, before that, let me just explain what I did here. So the selectors, what we want to do is from this list, we want to compress this list so that the only elements we have in this list are whichever element in selectors is true in the corresponding index. So let's say in cities index 0 we have Atlanta, and in selectors index 0 we have true. That means we want to include Atlanta in our compressed list. Same for San Francisco. Let's look at index 2. That is the third element for Seattle. The index 2 in selectors is false. That means when we're creating the compressed iterator, we don't want Seattle in it, and the same in Houston. So let's go ahead and do it. So let's do compressed cities, and then we just want to do Itertools.compress. We pass it our data, which is going to be cities, and then our selectors. So I just named it selectors for convenience. You can name it whatever you want. And then let's just loop through it and print out the city. There you go. Okay, let's run it. As you can see, in our compressed cities iterator, we have Atlanta and San Francisco, two of the elements for which in the selectors list we had true. For the other two which were false, Seattle and Houston, we don't have them in our compressed cities list. The operation stops when either the data or the selector's iterables has been exhausted. So if you had like multiple more here, if you had like more over here, but your selectors, you had 4 selectors here, but you have 1, 2, 3, 4, 5, 6 cities. So your iterator that is going to be generated here is going to only consist it's only going to operate till Houston, because when it goes on to operate onto the next element, it doesn't find the corresponding selector, so it just stops. There you go. These are some of the most overlooked functions in Python that can help you write more functional code and deal with data structures more efficiently. Hopefully you have learned something new from this video today. If you did, please like and subscribe the video. See you all in the next one. Thank you.